Hey, good morning, everyone. Let's see. We're going to start up here in just a minute. All right, it's 11 o'clock. I'm going to give everybody just one more minute here to log in, make sure everybody's got a chance to get in, and then we'll kick this off. All right, good morning to you too, Bill. I think it's 11:01, so we'll go ahead and get this kicked off here. Let me just get ready. Okay. All right, so I'm sure you guys all saw the link. We're going to do a follow-up webinar to our previous reverse engineering webinar of our aircraft winglet. So in the last one, we actually took this scan of this part and reverse engineered it back to a CAD model. And this one, we're going to take a reverse engineered CAD model and we can compare it to the scan. All right. So just to give everybody a little bit of an introduction, I'm Kenny. I'm one of the engineers with Neometrics Technologies. I'll be your host today, and let's go ahead and get started. So this guy is, let's see here, make sure there we go. Okay, so again, I'm with Neometrics Technologies. We do 3D scanning, reverse engineering, and inspection. We sell the equipment and the software, and we also provide the service to get your part. So you see over here, we got the object into a scan data set, and then we can either generate a 3D model or we can generate an inspection report. So in this one, we're going to go with the inspection workflow. And we're going to do that. We've got a few different software packages for that, but with Geomagic, kind of the one we use the most is going to be Geomagic Control X. So this is our fully featured reverse engineering, inspection software. So we can apply color maps, dimensions. Down here, we can do corrosion and damage analysis. We can do all kind of stuff with this software, so it's very versatile. A really nice thing about Control X or either the Geomagic products is your CAD imports. You just buy the software and you get your CAD imports, so no worrying about whether you've got the correct translators, whether coming from internal sources or you've got external models and they send you the wrong version. We can import any of the polygon scan models essentially as well. All right, so we'll go ahead and kick it off here. This is the Control X interface. Very similar to Geomagic Design X, very similar to any of your standard parametric CAD programs. They lay all the tools out in very similar tabs. So you see, we got a home tab, which I like to spend a lot of time here on the home tab. It lets you use a lot of the main functions of the software. Okay, we've got a little bit of mesh editing stuff, but we've got our full featured alignment tab, our comparison tab, dimensions, and a few others here that we've got some extra tools in. I'm going to stick mostly within here. I'm going to click import. We're going to import our CAD, and we're also going to import a scan. So first thing I'm going to do is import my CAD model. We're going to go to Winglet fitting model. All right, and there we are. So same model we ended up with last time. Okay. What I can do with this software is I'm essentially writing an inspection project, a program that will extract dimensions from our scan data I'm about to import with respect to the CAD model. So it's going to give me my nominal dimensions, which are the CAD model dimensions, and then how far out the dimensions of the real part, the scan part, are. A huge advantage of this workflow over something like a traditional CMM is with a CMM, generally you have to wait for a part to be manufactured to write your inspection program. Adds a lot of downtime, a huge space of time between your first parts made and when you can actually go to real production. With this workflow, I can bring in my CAD model. I can actually apply all my dimensions, everything to the CAD model itself without scanning first. And that way, when my first part is manufactured or prototyped, I'm ready to go. With that said, I'm going to go ahead and import the scan, because if I want to build a permanent workflow, if I have the scan in here, I can check every step of the way to make sure nothing, maybe an alignment doesn't fail or some sort of extraction doesn't fail. That way I know that my downstream scanning inspections are going to work. So I've got my scan here. Okay, so I want to, first thing is get it to my CAD model, all right? So it's just out in space floating around. I want to overlay it on the CAD model. First thing I do with pretty much any scan data set is to do an initial alignment. So what this does, I'm going to click my checkbox, and it's going to try and find a good fit between the scan and the CAD. So very quickly aligns those two. The software has got great alignment algorithms, so very rarely do I have to go and do some sort of extra pick point alignment to get them to align. That's my first step. That's the initial alignment. We can refine it from there. Okay, I've got a best fit, which I can use, so it takes my local alignment and it kind of, makes sure everything is as close as it can possibly be. With aerospace parts, a lot of the times we're going to have a datum alignment. So you can see also here in my alignment tab, I've got the datum alignment feature. I'm going to go ahead and throw some datums on it. So we're going to click datum alignment. And this software is unique because I don't have to call out datums on my part initially to do it. I can go ahead and just click my datums and then apply those letters later. So my datum pairs, I'm going to choose a few surfaces here that are planes. I'm going to choose this bottom surface for A, which I'll go ahead and label later. But see, I click that as my primary datum. The scan may shift a little bit. That's fine. It's just best fit. It's best matching that surface up. But when I go to choose my secondary datum, you can see here it's going to fit it back quite a bit better. And then as I choose my tertiary datum, this face here, we've got a really nice alignment there. Okay, all my degrees of freedom are locked, so I can go ahead and click the checkbox to tell it to accept that alignment, and I'm ready to go. Now this alignment, we've got some alignment statistics here. I also, as I build my program, I want to think about what my report wants to look like, what I want it to look like, what I want to give to maybe my manager or somebody. So here's where I want to get a good snapshot of my datum alignment. Okay, so if I click up here on datum alignment in my tree, the software it gives us a pre-made, if you see it down here at the bottom left, it gives us a pre-made snapshot of what that's going to look like in our report. And I can preview the whole, in large view by clicking the apply viewpoint right here. And if I look at that, that doesn't really give me a good view of my datums. You can see the flag callouts, but I can't really see where they're pointing to because all those surfaces are underneath my view here. So I'm going to rotate this around. Okay. And then what I want to do is label those datums as well, so we know what A, B, and C are. So I'm going to do that under my Dimensions tab, grab my datum flags, and just click. I know that was the primary datum. That's A. We're going to click B. Again, you can do all of this independent of the actual alignment. And C. Now we have a clear view of what all our datums are, and I want to use this view for my report. So I'm going to click back on datum alignment. I'm going to choose this Reassign Viewpoint. And now you can see down here on the left, I'm going to slide it over just a little more. Click that one more time. And that's going to give us a really nice view of those datums for the report. So if somebody's looking at this, not familiar with the part, they're good to go. I use this quite a bit, so you see me use it a few more times within this webinar. Moving on, I've got my alignment. Everything looks really good. I'm going to hide my datum alignment features. I'm going to hide my scan at this point. I don't need to really see it anymore because I know it's aligned, so we're good to go there. And I'm going to go down and hide my A, B, and C datum flags. Now I want to go ahead and throw in some dimensions. All right, so I can do that in my dimensions tab, same place I just put my datum flags in. I've got a whole bunch of options here. I can use linear, angular, radial, and elliptical dimensions. And how that works, I can click right on that linear dimension. Let's just do a linear dimension right here. And I can choose directly on the model itself, which is really nice. I don't have to go create features. I'll get to why you would use these over here in just a few minutes. But I can just use the CAD faces themselves. So I'm going to click one plane. I'm going to drag my mouse up here, click this plane, and I can drag a dimension flag out there. So I can see that my nominal dimension, all right, 5.53 inches, plus or minus a tolerance of 50 thousandths. So if I want to reduce that tolerance, maybe say to 20 thousandths, I can choose my tolerance right here, click my checkbox, and I can see there that that's my dimension flag. So just that easy. Click in a couple of faces, you get your dimension between them, and you're good to go. All right, so I use linear dimension. I really like to use a smart dimension. And what this does is it toggles between the four of these depending on what you select. So it's got kind of a predictive selection. So if I want to choose this cylinder, maybe I want the diameter of that cylinder. I'm just going to click right on the cylinder face and then place that place that dimension flag out here. But watch what happens if I click a cylinder and then click another cylinder. It automatically switches to a linear dimension. It knows that I'm trying to take the dimension between those two. All right, so then I can click this, apply it in space. Okay, and we'll try to do a dimension between these two angles. So I'll click one plane, click another plane, and you can see there it's now toggled to an angular dimension, all right, because there's an angle between those two. What I really like about this software as well, it's very easy to reassign nominal values. So these values here that are in the colored box, those are they're the nominal dimensions, so they're what the CAD body actually is. So if I look at this part, 59.987 degrees, your drawing probably calls out 60. Maybe somebody who made this model wasn't all that careful with how they made that angle. So I can double click that and I can reassign that reference tolerance to be 60 degrees. So I can override the dimension. And that's a pretty big tolerance there. Not sure why it's 25 degrees. So we're going to make this plus or minus 0.1 degrees. Okay, and you can see there it updates my tolerance color. So it's giving me a warning that I'm close to being out of tolerance, but it's yellow. I'm still in the good. So that angle's still good. Along with those dimensions, I have my full featured set of GD&T, so we can choose any number of those. I can use let's say a surface profile. I know these surfaces are not planes, they're more of as you see there, it's a free-form surface. So I can click on that surface, apply a surface profile tolerance to it, okay, and I can choose to show the fitting deviation so I can see just how far out. I've got it pretty tight at 10 thousandths, how far out that surface falls from the CAD body. I'm going to up that tolerance a little bit. I'm going to make it, let's see if 0.2 works. That's probably a little more of a reasonable number, 20, 30 thousandths. So we can kind of increase that however we want. Okay, I can also do maybe a true position. And here's something that's going to throw me for a little bit of a loop. With a true position, maybe I want to do it on the intersection of this hole to this top face. I can't click on it because I can't click on the edge here because this surface is is kind of a radius. So I can't directly just click on it like I have in these other faces. So here's where I'm going to choose maybe to do a construct a geometry feature. So we're going to click circle. All right, and I'm just going to click the edge and it should extract that circular edge there, circle one. Now I can throw a true position tolerance on that circle, okay, and then maybe make it reference back to my datum reference frame. Okay, so again, maybe this is a little bit bigger. There we go. So we can reassign all of this stuff as we'd like to see it on, basically mimicking the drawing. I'm all done with where I'm going to go with this screen here. You can apply all the different dimensions all across the part. The problem is if you start applying them to the back of it, you get this big giant cluster of dimensions that is very hard to read. So what I like to do is break my views up into different groups depending on the view that I have on the screen. So a lot of times I'll break it up and do different views depending on how I have maybe a 2D drawing I'm trying to reference. I'll mimic the drawings. And here, this looks like a pretty good view. I'm going to click my group 1 under my GD&T and then choose Reassign Viewpoint to make sure that this viewpoint here, let me slide it over just a little more, get that centered down here, but that's going to be my view. So if I want to do another one, I'm going to hide that. Maybe I wanted a few dimensions on the back side. We'll do Add Group. So right now we're in 3D GD&T group 1. I'm going to say Add Group. That's going to make a second group in my tree. Collapse my first one there. And then I can go in and make a, let's say a smart dimension and make a couple other dimensions on the back side that maybe are a little easier to see from a different view. Another reason I would use my constructed geometry up here is if I want to make, let's say if we look at the top of this, I've got this plane that goes, maybe I got these 4 faces that are supposed to be coplanar, and I need to take a general dimension between that face and the planes on that face. I can't do that just by clicking on it with the smart dimension. I have to go grab my plane, make sure my method is under extract, and I can select all those faces. Now it's going to extract a measured plane across those 4. And I'll do the same thing over here. 1, 2, 3, and 4. Okay, and then I can go add my angular dimension between the 2. Again, maybe adjusting this to 7.7 degrees, putting my tolerance a little more of a reasonable number. There we are. All right, so once I get that done, I'll get it in a view that I like. Okay, and then click Group 2. Assign viewpoint to that view. That way, when my report spits out, I don't have to do any adjusting. It's going to look really good from the get-go. So that's our 3D GD&T, 3D dimensions. What we also have for 3D is another, probably one of the more common workflows that somebody's going to add to the report is this 3D compare. So what the 3D compare does, what we've just done is take a bunch of dimensions on our part. The 3D compare, I'm going to hide that. I'm going to hide my planes as well. If I click 3D compare, this gives us a surface tolerance. We call it a heat map or color map, whatever, there's a bunch of different terms for it, but it's essentially a tolerance map applied to the part, right? So right now I've got my tolerance set to plus or minus over here. They're about plus or minus 4,000. So I'm going to make that plus or minus 10. Probably a little more reasonable number for this type of part. It's a fairly large part. So now I can see that anything that's within green is within my stated plus or minus 10 thousandths tolerance. And you may find that on a 2D drawing as a maybe a profile tolerance across your whole part. So this is something that's very easy to have set on a report. Somebody can look at that page and very quickly see areas of concern. And you can even call them out with a few flags. So if I click directly on the model, you can see there I can apply some dimension tolerance flags. So we can show somebody who's looking at this report very quickly where our problem areas lie. So again, very easy thing to show somebody, give them information, a lot of information right up front as to how their scanned part matches up to their CAD model. So I really like this. Tool. We're going to leave that as just the default, or maybe we can. Let's go to 3D compare. We'll reassign that. That one looks pretty good. That view way down there, but we'll keep with the same view that we're going with. Okay, so we've done 3D dimensions and we've done a 3D color map. Those tools both have kind of sister tools. We have 2D dimensions and we have a 2D color map. I'm going to go through those now. So the 2D dimensions, we're going to go back to our dimensions tab, okay? And right now we're working in 3D. I can click 2D, and I do have to click Add Section. And from here, let's hide our color map. From here, I can choose my base plane, so I can decide how I want to cut my part. But maybe I want to do something like cut a cross section between or through maybe these circles down here. I don't have a good plane to select, so I'm going to build one real quick. Okay, so we're going to go back to 3D, and I need to build a plane on this face. But if I look at the if I look at the CAD, these holes aren't normal to that face, and the face is a freeform. So I've got a couple of problems there. I'm going to create a plane that's normal to the extrusion direction of these cylinders. So what I can do is choose vector, go to find cylinder axis, and you see it's going to extract the cylinder axis from that and give us a vector. And then I'm going to choose a plane that I'd like to do my cross section on. And I'm going to work with the pick point and normal axis method. So it's going to, when we click the axis, I'm just going to click a point. I can click any of these here. And you see that it's going to create a normal plane to that axis. All right, there's my sketch plane. So that's the plane I want to use for my cross section. While I'm going through all this, if you got any questions, you can go ahead and ask them in the chat, and I'll get to those towards the end here. I can run back through any of these tools. So just as a quick reminder, don't be afraid to ask any questions, and we can revisit anything. So I'm going to go back to my 2D, okay, and I'm going to click Add Section. And instead of clicking one of my planes here, I'm going to click directly on plane 3. All right, so here what I want to do is trying to figure out what cross section I want to use. I want to offset it down into those those holes a little bit into that CAD. So I grab all of them. And if you only want to do, like if you got a partial cross section, you can close up that cross section some, so that way you're only concentrating on a few features. So it just depends on what you're modeling or what you're extracting there. I see Derek asked a question. Even though you hit the scan when measuring, aligning, etc., is the model is using the scan. So yes, so even though I hid everything, I've hid the scan. It's using the scan dimensions. The scan just hidden, so we don't have to worry about clicking on it or seeing it. Everything's going to be, all these dimensions and everything are applied to the CAD model and then extracted from the scan. All right, so here we go. Here's our cross section. And just like with the 3D dimensions, we have our 2D dimensions. Same sort of tool set. So we've got I'm going to go right into our smart dimension here, okay? And what I can do with this, just like in 3D, I can click right on a circle and place that dimension flag in space. I can turn my tolerance, adjust that to whatever I need it to be, okay? And I'll go ahead and do another dimension between the two circles to show you one more aspect of this tool here. So if I click too much here and get out of that. All right, so if you put too many, we just click on the dimension, say delete. So I'm going to back to smart dimension, click on one circle, click on the next one. And here's where I can choose. I've got a few different items I can choose here. So if I've got an alignment, so let's say I do between this circle and this circle. All right, so right now it's giving me a 3D dimension between two centers. If I want that to be on an X or a Y axis, I can click alignment and then choose X or Y axis. All right, so maybe I want to place a dimension out here, or let's do one up here. Another option I have right now, it's measuring the centers. Maybe the dimension calls for, maybe it's 2 pins, whatever that cross section is, maybe it calls for a maximum dimension between those two holes. So I can go down here under arc conditions and click max for both of them, and it's going to give me a caliper dimension on the tangent, the farmost side of each of those. So now instead of having a center to center dimension, I've got an exterior to exterior. Similarly, you can click 2 here and then maybe do a minimum dimension between the two. Okay. Same rules apply as well, GD and T, so I can do a true position. So let's say we do it on this guy. On any change our dimension, you can apply that there. So any of the stuff, or most of the things you can do in 3D, you can do in the 2D in any sort of cross section. So get out of our cross section. I'm going to click that button there. Okay, and you see my dimensions. I'm not going to worry about reassigning that viewpoint because it's just going to be the same cross section that it shows in my preview. So last thing I want to show, last of the most common tools, is doing that same sort of measurement. We're going to go back to the Home tab, or you can go to compare, either one, but we've got the 2D compare option. So similarly, it's going to ask us to do a cross section. This time I'm just going to choose one of the standard planes. So let's do this guy here. Let's do the Y plane. Now I can offset that cross section anywhere I want in my model. Okay, so let's run it right there. All right, and make sure it's bisecting the entire model. And this is going to look very similar to our 3D compare. All right, so we've got a Whisker Multiplier. When I drag this up, if any of you sat in on our Design X demo, this is a very similar tool to your cross-sectional accuracy analyzer, right? So you can drag your whisker plot up, kind of exaggerate the deviations along that cross section for the viewer. So we're kind of setting this up for somebody who's going to review this, all right? And then we can see our tolerances there. So maybe on this cross section, you've got a profile tolerance of this specific cross section of 5,000. So we'll go ahead and leave it at 5,000. So it's a little bit tighter than the 3D compare. And just like with the 3D compare, 2D compare, I can click on areas of concern, and it's going to give me that deviation flag in that location. All right, so I'm going to click my checkbox, and there we go. That's the last tool I'm going to run through on this. So you can apply as many dimensions and color maps and things like that, thickness checks, anything you want to do to this part. At the end of the day, what we're going to look for is exporting an inspection report. So we do that. Home tab, pretty much how we've been saying for everything except for the dimensions. Right at the end is generate report. And I love this report generation tool. So we're going to go into generate report. What it's going to do is give us a preliminary report creation page. So I can choose the template. I happen to have my own Neometrics template here, so one that I like. You can fully configure, fully customize your own report template. So that's what I've done with this one. Okay, for every single page that you could possibly have in here. And then I can go in and choose what I want to, throw in my report. So if I look at this, my initial alignment, that was just our kind of quick alignment to get the scan to the CAD. I don't want that in my report because it doesn't mean anything, right? My datum alignment kind of supersedes that. So I'm going to click initial alignment, and I'm going to choose this, send back to the table, basically, get it out of there. Same thing. So my circle one, my plane one, my vector one are all features I really don't care about that much. So I'm going to send those back to my report. All right, another thing I can do here is I can configure my report. I can align it however I want. So maybe I got my reference data, measured data, so be some pictures of my data, datum alignment, and then I've got a 3D compare. Maybe I want my 3D dimensions to come right after that. So I'm going to click group 1, move that up, group 2, move that up right behind group 1, and then have my 3D compare one. All right. Oh, move that up too far. That's all right. That'll stay right there. And then we have our 2D dimensions and our 2D compare. All right. So we've got them kind of laid out in 3D groups, then 2D groups. When I come down here to the bottom, I've already got everything inputted. So this is really nice. You can go ahead and put all your info in so you don't have to do it every time. All right. So that's all my information I want projected to the first page of my report. So all I got to do is click generate. It's going to open up a new window. All right, and what it's doing is it's taking all the snapshots, all our dimensions, throwing them into tables that are going to project to an inspection report. There we go. I got our banner here. We've got our preliminary info, so it's our inspection demonstration. If I scroll down, I've got my reference data, so my isometric views of the CAD file, or sorry, of the scan data. There's my datum alignments. Remember that snapshot I took? I reassigned here. That's what I want to see. So this very clearly shows somebody that my two data sets are aligned. All right, and as we move to our 3D dimensions, or we call our group 1, okay, so there's all of our dimensions called out in the different flags, our profile tolerance with that color map on that surface, and then the next page contains all of that information. So we got angular dimension 1, linear dimensions, radial dimensions. All that stuff can be projected in there. All right, same thing, group 2, as well as its information. So again, we got tolerances on each of those, actual values, reference values, everything for someone to review. 3D compare, there's my shot of my, really nice shot of my pretty good CAD model with a couple of areas of concern flagged. And then now we move into 2D. So 2D cross section shows down here. I like this because it gives us that cross section location, so you know exactly where this is taken very clearly. And same thing with our 2D compare. Same thing, gives us the cross section location, but gives us all the same information as our 3D section. Your percent over and under tolerance, all that kind of stuff. So once you get done here, you can export the report. You can click PDF, PowerPoint, Excel, whatever you prefer to get your, however you store your inspection reports. I'm going to minimize this window, and the big, huge advantage with this software, the next one, is to do the next part. I've already set up my report, right? So I don't have anything else that I have to apply. I know everything works. I know everything extracts. So if I want to do a second part, maybe I've scanned 10 of these winglets. What I'm going to do is come up here, right click on result data 1, and I can do add result and, you know, name, let's call it result data 2, copy from result data 1. Okay, and what that's going to do when I click my checkbox is it's going to completely copy everything from that result data 1 into result data 2. So there I go. I've got the same exact inspection report. From here, what I'd like to do is get a new scan. So if I brought a, you know, if I've scanned 2 or 3 winglets, I'm going to say scan 2. We're going to come right up here to replace measured data. Okay, and then for us, I've got the same one. So I've just got the one scan, but let's say winglet scan fitting 2. You would click on it, run inspection process. For me, because it's the same name, it's going to come up with a flag here. Would you like to you know, replace the measured data and everything? I'm going to say no. Generally, that's not going to happen if you've got more than one scan data set. But what you end up with, it's right now it's running through its whole inspection program. And then when I open up my report, it should generate the exact same report. There we go. So this one, just to show you that it's a different scan, if the scan's purple, that's fine. But here, do generate report, and you can generate the exact same report. It's going to give you all the options again, but it's going to spit out the same data, just updated for that new scan. All right. Another thing you can do here that's really nice is you can do a batch process. So if you have maybe you've done 100 of these, let's say you know, a whole bunch of the same part, and you don't want to go through this process, you can do what's called a batch inspection, where you can put all those scans into a folder, and then you can run the batch inspect on this software. It will, behind the scenes, run this inspection over and over for each of those scans within that folder and spit out the reports, whatever PDF, Excel, whatever you want it to be. So you can very quickly run through quite a few parts, you know, with basically only spending the time setting up one and then scanning them. All right. So that's what I've got for this inspection webinar for this winglet scan. So now's about the time. If you guys have any questions, you know, let me know. Go ahead and type them in the chat. I'm going to run through them here. I'll give you guys a few minutes. Let's see here. Scott, so can you save the CAD model setup to reuse the dimensions for multiple scans? So yes, that's exactly, so you probably typed that before I ran through that. So it's exactly what we just did. We save this part here. You can do a menu file, save as, and save this as your, you know, your default, let's say winglet. Okay, 1T, okay. And you can, at that point, open this up at any time. If you've got a project, maybe you've got 10 more of these that you need to scan and inspect 2 weeks from now, open it up, go to your, you know, whatever result you want to copy that result to a result data 3, bring in your new scan and run that exact scenario again. All right. Can I use a scan of a good part as opposed to a CAD model? Yes, you can do that as well. So instead of doing so if I do let's see here, I'm just gonna say add result, none. So we're gonna work with a new one. Okay, so I can import just a scan. All right, and let's see here. I think that's all I need to do. So import. So I'm importing the scan first. So there's my scan. Now I can right click on that and say move to reference. And so from here, it's going to, you know, mesh from CAD model, mesh from scanning. So if you have an STL that somebody's maybe sent you generated from a CAD model, you can click this and say make. You don't want to do that with the scan because of how it tries to break up the mesh. So I just want to do straight mesh from scanning. Okay, and what that's going to do is it's going to kind of get that ready for inspection to, let's say, maybe in this scenario, for those of you who may not know, maybe you don't have CAD, but you have a part that you know works. You know everything works on it. It's been working forever. Everything checks out. And you need to know if the second part you make or the second part you have is close to it. You can scan that good part, import it, do just what I'm doing here, and then bring in your unknown part, right, as a scan, and then you can do the same alignments, and you can do your color maps and things like that. So that is something we can do in here. All right, so it's still thinking. This process does take a minute. It's trying to get the scan kind of ready to extract in a little bit different way, you know, than just extracting from the scan. So, I'll run through that here in just a moment when it gets done. But let's see if I've got any other questions while we're waiting on that. Doesn't look like it yet. So those were the two last questions I see. So. Okay. And this is the reason it's taking a little while is it's a big scan, right? So there's a lot of triangles in there, so you will have to wait a minute for this to happen. All right. Anybody else have any questions for me? You might need a supercomputer. You do need a computer that you can run. You know, it needs to be able to run your standard CAD program. So if you're working in SolidWorks, working in Inventor, whatever that CAD that engineering workstation is, it should be able to run this no problem. So so you don't have any issues there. But if you see what it did, so it does break the mesh up into it's almost like the regions. If you watch the reverse engineering webinar, but it's trying to create features. So you can see it's got planes. So what we can do here is import that scan, but it's trying to create reference surfaces that it can extract features from. All right, so there's my scan. Let's see where it's at. Okay, so if I hide this, let's make my scan. Let's see if I can make it a different color. Just so we can see what's going on here. All right. Oh, frozen up for a second, so give me a moment. All right. Okay, so now let's see if I can hide that. So now let's see, I've got those aligned already. Let's see if it'll let me run a 3D compare. And frozen up. No, got a selection toggle on here. Well, so at this point, I'm not sure exactly what's going on, but you run your 3D compare, you should get your tool that comes up, and you can run your 3D deviations. That's usually what people are looking for when they're doing this sort of thing, where they're inspecting a new part to a known part. But we can also go in this instance, we would have to apply planes and things like that to our, here we go. There we are. You'd have to apply planes and things like that to the part itself, to the scan data first, to the reference scan data, and then that would pair to the nominal. So you can still do this inspection as well. All right. Well, that kind of, unless I see anything else, I'm just going to kind of let this sit here. So if you guys have any other questions, I'll give you one more minute, and after that, we'll kind of wrap everything up. Anything I missed here? All right, I don't see any new questions coming in. Let's see. I think we're good. So do we offer inspection as a service? So we do this as a service as well as we sell the software. So if you have a few parts that you need done, you can send them on into to our office. We can scan them here. We can go on site if that part is, if it's really, if it's a large part that can't be sent anywhere, we can take that scan data and then we can bring it back and apply it to a CAD model, or do whatever we need to do with it. We can inspect and we can reverse engineer. Okay. All right. Well, thank you everybody for joining. I'll go ahead and wrap this up. I hope you guys have a good rest of your day, and see you next time.